Lesson 2.6 is motion rates. We're headed to the races, everyone. Our target for the day is that I can solve problems and compare and convert motion rates. Vocabulary. First off, we just used a word. We're not sure what it means. What is a motion rate? Well, we know what a rate is. A rate is a ratio that compares two different units. A motion rate is a type of rate that compares distance to time. So, distance like miles, time like hours. So, miles per hour is a distance rate, a motion rate, sorry. A rate conversion, we've done a little bit of these before. We've done unit conversions. Now we're doing rate conversions, which is the process of changing at least one unit of measurement in a rate to a different unit of measurement. Using my miles per hour example, that would be like going from miles per hour to miles per minute. Did you know that meters per hour, feet per hour, and inches per minute are examples of motion rates? Distance can be measured using customary inches, feet, miles, etc., or metric units such as millimeters, centimeters, meters, kilometers, and so on. Time is most often written as seconds, minutes, days, hours, weeks, months, or years. There is no metric or customary standard for time. Everybody uses the same time. To convert a rate. First, write the rate as a fraction, simply because that makes it up and down and most compact and easiest to see what you're doing. Second, identify the units you want in your answer. Third, multiply the original rate by a conversion rate using equivalent measurements. Make sure the unwanted units cancel out to get the answer. I'll explain what that means later. Example 1. Oksana's family traveled on a highway at a rate of 60 miles per hour. Her family traveled at this rate for 2.5 hours. How far did they drive? So this is one of the problem solvings. Not converting it, just problem solving. Let's find the unit rate first. They're traveling 60 miles per hour, which is the unit rate, 60 miles per hour. After writing the unit rate, set up the equivalent rate next to it for the amount of miles they are trying to find. So, how many miles did they travel in 2.5 hours? How do we go from 1 hour to 2.5 hours? Well, we multiply by 2.5. Same thing we do to the bottom, we do to the top, and we get 150 miles in 2.5 hours. Example 2. Wayne and Marla each left home on their bikes. They were meeting at the library, which is exactly the same distance from each of their homes. They're equidistant, you might say. Wayne traveled at a rate of 20 miles every 2 hours. Marla traveled at a rate of 6 miles every 0.5 or 5/10 of an hour, half an hour. They left home at the same time. Who arrived at the library first? Well, to find who will arrive first, we need to find the unit rate for each person. This will tell us how fast each person is traveling. So let's look at Wayne and Marla. We've got Marla on the left and Wayne on the right. I think, yes, we do. So we've got 6 miles for every 0.5 hours on Marla's side and 20 miles for every 2 hours on Wayne's side. We need to find the unit rates. Sorry, the cat moved the mouse. There we go. Marla, you can see there, needs to multiply her hours by 2 to get 1 whole hour because she's not traveling 5 hours, she's traveling 0.5 hours. So she's going to multiply her bottom by 2 and her top by 2, which means she's traveling 12 miles per hour, a respectable speed on a bicycle. Not terribly speedy, but not meandering either. Wayne, to go from 2 hours to 1 hour, needs to divide by 2. And when we do to the top what we do to the bottom, we find that he was traveling 10 miles per hour. So, excuse me, which person can travel farther in 1 hour? That person will arrive first. Well, Marla's traveling 12 miles in 1 hour, and Wayne's only traveling 10 miles per hour. Tavildo is traveling no miles per hour, but he is getting off my lap now. Marla is traveling more miles in 1 hour, so she will arrive first.